Jai Hind all. Myself Amita Asthana from Ajay Kumar Garg Engineering College, Ghaziabad. So here in this video lecture, I have taken one topic from Unit 5 from the subject Fundamentals of Electronics Engineering, code being BEC 101. The topic is Amplitude Modulation, and some part has been covered from the data communication. So here, coming to the amplitude modulation, how these amplitude modulation have been done. In the last video lecture, we have discussed that let's say I have one modulating wave MT and another is, this is the modulating signal, and this is a carrier signal. What we do is we just multiply them together. Okay, so we multiply them, but before multiplication we need to raise some sort of DC level of my modulating signal. So what we do is, here the one signal we can take as V1T and another one is V2T. This is my square law modulator circuit for the amplitude modulation generation. The carrier has been given. Here I am giving my carrier AC cos omega C T, as we have already discussed, and this is my MT AM cos omega M T, right. Now this V1T is MT plus AC cos 2 pi FCT. So what I have done is I have summed these two signals. So the V1T output is nothing but MT plus AC cos omega CT. Then what I did is I just passed it V1T to V2T. Okay, V1T to V2T. So what I am doing is I am making the square of this particular signal which is coming out from the summation V1T. So I am passing it to square law device, and the output V2T from the square law device is nothing but some, like whenever we square, some square signal is there and some non-square signal is also there. So the non-square signal I have taken some constant K1, for square signal I have taken some constant K2. So K1 V2T will be K1 V1T plus K2 V1 square T. Now just we will open this and then we will calculate the V2T. So V2T, if I say, then it will be K1 MT plus AC cos omega CT plus K2 MT plus AC cos omega CT square. So this is my V1T square and this is my V1T. Now I will calculate my V2T and solve for this particular. So whatever K1 MT plus K1 AC cos 2 pi FCT K, and this is from K1 V1T. Now K2 M square T plus K2 AC square cos square omega CT plus 2 K2 MT AC cos omega CT. So these three terms by squaring the V1T, right. Then V2T will be K1 MT plus K2 M square T plus K2 AC square 2 pi FCT. And in the last term, what I have done is I have just taken the K1 term constant, and this I have merged with this particular, and then I can take K1 AC from these two terms, this term and this term, right. So I can take K1 AC common, 1 plus 2 K2 upon K1 empty cos 2 pi FCT. Just nothing but we are just solving. So in this way, the last term of the above equation represent the desired amplitude modulated wave, and the first three term of the above equation are unwanted. What does it mean? What has been explained is, let me delete this. So these, out of these 1, 2, 3 and this term. Okay. So what has been said is the last term of the above equation, this term, the last term of the equation is my amplitude modulation, is my desired amplitude modulation, and first three terms, that means these three terms are not wanted, okay, unwanted terms, and that can be removed with the band pass filter, and only AM will be passed by the band pass filter and ST is obtained. The final term, that means I have got 4 terms after passing my V1T from the square law device, and from V2T 3 terms have been removed from the V2T, giving the output to be equal to ST, and the last term only remains, and that is my amplitude modulated wave. So in this way we can remember. So my ST is K1 AC 1 plus 2 K2 upon K1 empty cos 2 pi FCT, and this is the output of square law modulator. So here amplitude modulated wave can be generated from square law modulator circuit. First is the summer, second one is the square law device, and third one is the band pass filter. So summer is adding my carrier to modulating, then square law is squaring the signal V1T, and band pass filter is removing first 3 components from V2T, leaving only 4th component, and the 4th component is known as amplitude modulated wave, and that is equal to ST. So ST becomes this equation, in which I will do some changes, like ST is K1 AC 1 plus 2 K1 K2 upon K1 MT cos 2 pi FCT. This I will remain like this. So this AC I will remove, and here this K1 I will divide, and I will write the total constant by some approximation. I will write AC 1 plus Ka MT cos 2 pi FCT, where Ka is the modulating index, that is 2 K2 upon K1. So this is the final amplitude modulated standard wave equation which we need to learn. Now we have converted our modulating signal into amplitude modulated wave. Now coming to the demodulation part, the process of extracting the modulating original signal. What was my original signal? Here we can understand, this is my original signal. Just to make it of high frequency signal, what I have done, I have included one carrier wave also with this, so that the frequency of the modulating signal can be increased. Now, but my desired signal, original signal, is only this. So I want to recover this original signal from the amplitude modulated wave, and that process is known as detection or demodulation. The process of extracting the original message signal, that is MT, from the AM wave is known as detection. So first we are doing the modulation from at the transmitter side. So what we are doing is at the transmitter, we are doing amplitude modulation, and after high frequency passing through the environment. So this is my receiver. At the receiver, I will demodulate. This is how we represent. At the transmitter side, we are modulating, and at the receiver side, we are demodulating. The circuit which demodulates the modulated wave is known as demodulator. So the AM wave we have already seen. This is the RF signal or AF signal. RF frequency can be only transmitted through the environment. Not very less frequency signal can be passed. That's why we are converting it through amplitude modulation. So there are two types of demodulators or detectors. First is a square law demodulator and second one is envelope detector. Coming to the first one. So what we are going to do? We have received amplitude modulated wave at the receiver side. So we will pass this amplitude modulated wave through square law device, and then we will pass it through the low pass filter. This is the concept. Square law device and then low pass filter. So first of all, amplitude modulated wave which we have received after passing it through the environment, the receiver which it has received the signal, first it will square it and then it will filter only low pass frequencies, because my original signal was very low frequency signal and I want to recover that only. So I need to put a low pass filter into my demodulator circuit. So the standard wave, AM wave, we know that AC 1 plus KAMT cos 2 pi FC T or cos omega CT. So now we are going to pass it through the square law. So again we will square this received signal and we can get the terms, and then see FC is high, very high. So 2 pi FC is so much high. Again this 2 FC is high. Okay, this is the constant DC term. 4 FC is very high. Again this signal, after is passing it through square law, only this MT K2 AC square K square M square T. So this is these two frequencies. This is again high frequency signal and this is again high frequency signal. So only one signal we can left with, which is the massive signal with very less frequency, this particular part K2 AC square Ka MT. Okay. So this is the scaled version of the massive signal which we have received, because low pass filter can only pass the frequency within the range of modulating signal. Since FC is very high, what we have done is we have changed the frequency into FC. 2 FC is more higher than FC, 4 FC. So these frequencies we need to remove from the square law device. So low pass filter will only pass this MT and this MT with some constant or scaled version of MT. So that is how, by using only two components, we can demodulate the amplitude modulated wave. Second, the envelope detector. The second detector for amplitude modulation wave is very simple. It consisting of only one diode, one capacitor and one resistor circuit. This formos detector is the simplest, very low cost and made up of very low cost components. So here the performance, the RC performance is working just as a low pass filter, and this input has been given at the end from the diode, and diode will work as the same like for positive half cycle. It will it will work as short circuit, and for negative half cycle it will work as open circuit. Whenever it is forward bias, then this capacitor will charge, and whenever it is reverse bias, the capacitor will obviously discharge, and only envelope can be found after from the across the resistance. So the performance is not very high, but it is adequate for low cost AM broadcast radios, but it is not meeting other demodulation. So this particular circuit is rarely used for the communication, but we are using a square law device and low pass filter very frequently for the amplitude modulation communication. Now coming to the data communication part. What is data communication? We know the data is in the form of 0 and 1 only. Now the data is digital, 0, 1 is digital, and the data is the 0, 1 language is that only can be understood by the computers. So data networks are allowing computers to exchange the data. Now how we can communicate this data? This we will understand under this topic, data communication. So any two systems which we want to share the data, that can be connected maybe through wire or maybe through wireless. So there should be wired or wireless connectivity between the two terminals to exchange the data. So this is a very simple thing. So the data is flowing across the internet. The best known computer network is the internet. So the internet is the system of interconnected computers. The computerized peripherals, printers are known as computer networks. Now what are the characteristics of data communication? There are 4 characteristics which we need to understand: the delivery, the accuracy, the timeliness, the jitter. What is the delivery? That the data should reach at the correct destination, to the correct computer, to the correct device. I want to give the command to the printer, then the data should or the command should reach only that computer which I want, not any other computer in the world. Okay. So delivery is important. The accuracy, the communication system should deliver the data accurately. Whatever data or message I am forwarding to the system, other system, that should be received by the other system very accurately. Timeliness, within time. Data communication must be within time. If I have sent the data and it is reaching to the receiver after a long time, then there is no use of transmitting the data. Now coming to the jitter. So what is the jitter? Uneven jitter, that means the variation in the packet arrival. So that the large data, what is packet? Now coming to the packet part, let's say there is a huge amount of data. So what we do is we distribute the data into small packets. So this jitter should not be there. The timeliness, the packet arrival time should be fixed. So that timeliness, due to the jitter, if there is a variation in the packet arrival time, the timeliness of the transmission will be affected. Characteristics of data communication. In this diagram, one very beautiful representation has been shown for the data communication. Data communication is being held between the two devices. The networks providing networking services between two entities. The communication between two ends point is using protocol. That what is protocol? Protocol is nothing but set of rules. So residential user, subscriber connection, internet service provider, then some net link, SONET link has been taken. The router switches are employed which are routing my data. Okay, this router is going to the ATM switches. Again, there are some switches by ATM networks, and this high speed link is again being established between the firewall host, and the data is delivered to the private wide area networks Ethernet through via Ethernet switch. So we can see this is a switch architecture. This is a small, and this is the ATM switch architecture, right? So this is the data communication which has been shown. The data is going through the internet. There are various routers and switches being involved, and the high speed link can be established between the routers and the internet service provider, and the data communication is being done under the defined set of rules, and that rules are known as protocols. So these are very important points for the data communication. Now coming to the components of data communication. So there are 5 components for data communication. Sometimes the questions are being asked like, what are the components of data communication? So first one is message. Message is the information to be communicated by the sender to the receiver. That means the information in data form. In 101, let this is my data, okay, which I need to transmit. Now coming to the sender. Sender is any device that is capable of sending the data. So this is, first of all, a data should be there, then the sender which is sending the data, receiver. The receiver is a device that the sender wants to communicate the data. So the receiver is receiving the data, sender is sending the data, message is the data which needs to be transmitted. Then between the sender and receiver there must be a transmission medium, and this transmission medium may be wired or wireless, both. This wired by copper connectivity, or optical fiber, and this wireless may be Wi-Fi, Bluetooth, okay, GSM, like this. So this transmission medium may be wired, may be wireless, that we all know. Now the protocol. See, the data is being transmitted in a defined set of rules. That what are those set of rules that we need to understand? Let us understand that. Protocol is set of rules. Okay. This set of rules can be accepted by international or national agencies only. And what actually they mean? That let's say I have one set of data, I can transmit to any selected network, but my data should be in the form of the selected network's rules only. That means what are those rules and what they talk about. Let's say I have a data of like this. Okay. The selected rule says that at a time only you can transmit 4 bits. You can make a packet of only 4 bits. So what I will do? I will make packets of only 4 bits. So I will name as packet number 1, packet number 2, packet number 3, packet number 4. So this is a set of rule. If protocol is saying that you can make data packets only taking 4 bits at a time, so my set of rule will be 4 bits at a time. So this is one example which the protocol can tell about. Okay. So the protocol is a set of rules that governs data communication. That if protocol says only you can transmit one packet at a time, then I can only transmit one packet at a time. If the protocol says one packet should be only of 4 bits, then I will make packets of 4 bits only, not more than that. Otherwise, your data will be lost in the environment. So the communication follows some set of rules which is necessary. So the components of data communication here are message, sender, receiver, transmission medium, and then protocol. Okay. Now this is one simplified data communication model in which I have taken the source, then transmitter, transmission system, receiver, and then destination. So this is a general block diagram by which we can understand the data communication. So here example, this is my workstation. The workstation modem has been connected. This modem is connected to my public telephone network PSTN, and then again modem to my another end device. So now data communication source is terms of digital bit stream, input information, transmitter will take this digital bit stream and make it convert it to analog signal. It will modulate it in digital modulation terms, then transmission system will be taken, analog signal again it will be received by the receiver, transmission system it will go by the wire or wireless system, transmitted and then received the signal ST and then RT, then receiver will convert from analog to digital, to that will be analog to digital, this should be digital to analog converter, and then the destination will receive the thank you.